Okay, another example would be to think of these components as volumes that are predetermined and prearranged, and sort of work backwards and figure out how that you would create these volumes using a laser cutting process. So in this example, I have three volumes that are all the same and sort of overlapping and joining together, intersecting in the moment. So let's figure out how we can break these volumes down into a way that we can assemble this kind of composition using the laser cutter. The first thing we need to do is Boolean. And there's a couple different ways we can Boolean with Rhino. It's basically a geometrical process of removing one geometry from another geometry. If we just type Boolean two objects, you'll see Rhino will ask us to select two objects to Boolean. And so if we select both, and it says click to iterate through Boolean results. Here it seems to just join the two together. Here it's subtracted and kept only the difference. Here it's subtracted A from B, and here it's subtracted B from A. And set delete input to no. Okay, that's what we want. And let's put this one on first layer. Okay, so now we have this volume which has been Booleaned out in the shape of this volume. So now let's do the same thing between these two. And we can directly do Boolean subtract for this, or Boolean difference. And delete input to no. So here we have the updated volume. Okay. So we can copy this aside for the moment. And separate these volumes so we can see what we're working with. Okay. And just to get an idea of dimensions, it should be quite similar between all of them. This one's 20 millimeters by 80 millimeters. This interior should be 40, so on and so forth. Okay. So how do we compose this volume? Let's start with the simple one first. How do we compose this volume out of flat surfaces? And from before, we said that we were working with a material thickness of 2.4 millimeters and a width of the laser of 0.8 millimeters. So let's first start by exploding this volume, which is X. So we went from one polysurface into 6 surfaces. Let's hide the top and bottom surface for now. And remember that this was the maximum volume, and that anything that we do, we need to consider moving to the inside because we can't exceed this hole that we've created in the other volume. So let's do a command called offset surface, or just OO. Now it's asking for offset distance, which we know we want to be 2.4. We should flip this to the interior, and we want to select solid, which will create a volume instead of just another surface. So again, 2.4 is the offset distance. And so it's now basically extruded this surface. We could have also used the extrude surface command. So we now, instead of a surface, have a polysurface. Let's do that for all 4 of these surfaces to the interior. 4 surfaces that will close this volume. The problem is that they're overlapping. We can solve that with the scale 1D command, or just S. And if we scale from this end to this intersection, we now have a 90-degree joint there. Same thing here. We can just go counterclockwise around this surface. Alright, so when we cut these pieces out from the laser cutter, we can easily assemble them in this fashion. We're still missing the top and the bottom. We'll also want to offset 2.4 solid there and on the bottom as well. And we can select all 4 of these surfaces. And again, do scale 1D, this time from the middle to the edge. So we now have 6 planar surfaces, none of which are overlapping. So we could simply unroll these volumes using rotate 3D or RR. We'll shift to make sure it's planar. Okay. And then in top view, we can arrange these on a sheet. However, one thing that we're forgetting to do is to account for the width of the laser. So let's make a new layer, or we can use the cut line layer and create rectangles representing these volumes. Just trace over in the top equal. We can turn off this and set point shortcut is B to 0. Let's spread these out again. We need to offset all of them by 0.4 millimeters. And just delete the interior curve. So we're offsetting to the outside and deleting the interior. We can rearrange these on the cut sheet. and explode, select duplicates, delete, and delete any other things that we don't need. Alright, and so that will give us our necessary geometry to create a precise version of this geometry. Now if we want to create an even nicer or stronger version of this unrolled geometry, we could use what are called finger joints to create better friction and make a more solid joint. I'm going to use the helper layer for this, and first I'm going to create some guide curves using the duplicate edge command, or just DE. I'm going to duplicate this edge, and I'm going to copy this line 2.4 in this direction and 2.4 in this direction. I'm going to divide all these curves by some number, let's say 12. And then you can just draw a polyline to represent where these notches are going to go. Just one polyline here, and copy to every other. And another polyline. Okay, and we can delete these, and then you can start to see how this is going to form our finger joints. We can continue and do this around all the other edges. Alright, now you can see I started drawing the finger joint around the edges of the block. One thing that's useful is to sort of group this together as a single polyline and rotate 180 degrees around the midpoint of the block, which you can tell is here. Sorry. C for copying. 180 degrees. So now that's perfectly matching up with what we've got here. And we can do the same. Right. And then we just need to do the sides. Another thing we can do right now is to rotate this by 180 degrees as we did on the top. Just drawing a construction line here. And for this we can go into this right viewport and rotate, copy this midpoint 180. Okay. And we can do the same all around. So we can again rotate around here. Adds it down there. This group we can do in the front viewport. And this we can also rotate 180 degrees around. Okay, great. We can go ahead and delete these construction lines for the moment. On this side we need a new construction line, not going all the way from the bottom this time, but going from this point here vertical, V for vertical line to this point here. This we can divide, let's just do by 3. And we continue the same way. And same as before, we're going to want to copy this around. And if we redraw this top rectangle, and let's use a command called curve boolean, and click inside the region to keep. It's projected it downwards. Yes. Move this back up. And exploit this volume. Leave that. In our closed curve, we can extrude cap yes -2.4. And we can put that back on component 2 later. Component 1 later. Okay, and we can do a similar thing with these sides. Extrude inward. Get rid of this. Okay, so we can see how this is starting to come together. And continue for the bottom and other sides. Okay, we can see that the intersections are now pretty well resolved. The only issue is this overlapping of these corners here. So we can hide this top and bottom surface we can delete. And this we can hide for now. So let's duplicate these edges again. And let's divide these all by 3. Then extrude this, both sides, and use it to trim this geometry. And delete. So we're now left with this. Now we have these two pieces locking with each other. We can rotate them around. And move them back. Do the same thing to clean up these corners. Finally add the top and bottom back. Okay, I've now notched these sides so that each, the short side and the long side are notched on both ends. So here where I still have a dead intersection, I can delete these. And here, I can rotate, copy arbitrarily 180 degrees, and then move these back. Alright, I now have a completed finger joint box. I can select the curves and delete. Now I want to lay all these out flat. Right click to repeat the command. And then top view, spread these out a bit. And I want to duplicate border. Duplicate edge. In the front view, I only want, say, the bottom edge. So I'm asking you to duplicate just this. So I can move right here. So now we basically just extracted the curves. Then on our cut line layer, join these together, and we need to offset again to the outside by 0.4 millimeters. 0.4. Turn off the helper layer and move these back together. As you can see, they won't fit back together anymore. And it's ready to cut.